Inductive reasoning and conjecture. This is going to be the first dip into math that you guys don't really have. There aren't a lot of numbers. There aren't a lot of... and you just complained a second ago about our proofs are awful. That's all proofs are. Proofs are reasoning. What can you say from a given situation? What can you say from a definition? What can you show from something like that? Okay? So if I'm working through stuff, good morning, sir. How are you? Great. So what we're going to do is we're going to talk a little bit about what's called conjecture. Conjecture is like a hypothesis in science. In science, you make a hypothesis on something because it's called an educated guess. People do that all the time. I could stand and give an educated guess that Mrs. Thrower is about 5'5".
Nope.
And that's an educated guess. What about me?
I would say 5'4".
Whatever.
I'd say 5'3".
You know, the idea is that I know she's not 6 feet tall because I'm taller than 6 foot. And just as a quick educated guess, it's about 5'5".
About 5'3".
Okay.
5'3".
How tall is she?
Taller than
5'4"
me.
is not more.
You're about 6'5".
She said she's 5. You're taller than her?
I never like student next.
Yeah, I'm 6'3".
She was 5'3".
Yeah, no, you're taller than me.
Kill.
No, actually, I thought you were taller than me. Yeah, you're a little bit, it's the hair. Yeah, you're about 6'4", I'd say. So then that's the idea. You take an educated guess of something by looking at the surroundings. Now, you think about this in geometry terms. Just looking at a quick diagram. What's an educated guess you can make of that diagram?
It equals 180.
They're adjacent angles. Very good. They add up to 180. Because you're using stuff of prior knowledge to make what's called a conjecture. You're coming up with a a hypothesis of something. Okay? Conjectures based on are made on base of observations of a particular situation. Example again, we're looking at that diagram of the two angles. Austin said they're adjacent. He's correct because he remembered what that definition meant. What he was using is what's called inductive reasoning. Looking at several different situations to come up with a conjecture. So we looked at it, and I think you said these guys add up to 180 because you recognized that it was a line. You recognized that you had two angles that shared a vertex. They were adjacent. They had nothing in between them, okay? So that idea here is using what's called inductive reasoning. You do this every day without even thinking about it. You guys are always thinking about situations. You're worrying about something that's going to happen. You're looking at, oh no, this is going to go on. This is going to go, oh no, I'm going to have this. Because you're thinking, oh man, Murphy's going to assign me homework. That sucks. I don't want to do that. Because you are using your past knowledge of what happens. I give you homework. Dun, dun, dun. Things like that. Yes, sir.
Like right now, I'm sad because I forgot my iPod.
Okay, that's not using inductive reasoning. That's just the feeling.
But it's kind of a...
No, it's not. So it's not so much always just a math class that you're using this in. You, like I said, you use this in every single everyday life, whether it's looking at diagrams and pictures or looking at the weather. I mean, you're probably sitting there, man, it looks crummy out. Why do you think it looks crummy out? Because it's gloomy and it looks like it's really windy. And I remember that it's starting to get cooler out, which I love.
You like that?
So stuff like that.
I like the heat.
All right. So let me show you this. If I look at this picture, well, so you can read this a little better. If you read this, guys, if you read this, it says, please be safe. Do not stand, sit, climb, or lean on the zoo fences. If you fall, animals could eat you, and that might make them sick. Thank you. This is a real sign on a fence that I took a picture of, and I thought it was pretty stinking funny. But what could you come up with by reading this? What would you think logically about this picture? Whiskey, what do you got?
Let's pick up a little kid and throw it in.
Whiskey, that's not what we're talking about. Yes, sir.
They care more about the animals than your safety.
Exactly. Exactly. They care more about the animals than they care about you. Because what they're worrying about here is they're worrying about the animals. They're saying that animals don't like to eat humans because it makes them sick. Things like that. What about this? What can you say about that?
Somebody loves. Somebody's chilling.
The baby's really comfortable because he's sitting in his in his chair. And the sun is black because he's wearing sunglasses. You know that it's sunny out. What else could you say?
Like they're about to go in the pool or the lake.
About to go in a pool or a lake?
He's gonna drown.
He's about to go party.
Where do you think they are? On a boat. Why do you think they might be on a boat? Yeah, you're right. It was a pontoon boat. Okay? You're looking. Stop. Thank you.
Do you know this person?
Yeah. That's our oldest son a long, long time ago. But the idea here is you make these educated guesses each and every time that you look at a situation. This is nothing new to you. You guys are always making these inferences, excuse me. You're looking at stuff like that. For example, I'm looking at Mr. Pitts. He's not paying attention to anything right now, which means I'm inferring he's either one, playing on his computer, or two, on his phone. Which of the two do you think he's doing? There you go. Close the computer. I know you're not typing anything to put notes in it. Put your phone in your pocket. Thank you. Okay, then I apologize. Put your phone in your pocket.
I feel like we've just gone back to kindergarten.
Guys, Mr. Pitts, I'll take care of it. Okay? Another example. Getting into the geometry of things again. When you look at something like this, you are given 3 points. A, B, and C. You are given point lengths, segment lengths, if you will. AB is 10, BC is 8, AC is 5. Make a conjecture and draw a diagram. What can you do with this? Think about it. Think about it. Think about it for a minute. Give everybody a sec, Whiskey, okay? Think about what you can do. Draw it, make a conjecture. Draw it, see what you think. What makes sense from that information? What makes sense?
Nothing.
What do you mean nothing?
The AC is smaller than AB and BC put together.
Think.
Okay.
Think hard.
That's okay. But what can you do in a diagram wise? What are you gonna do?
It's a triangle.
Nice.
Oh yeah, I knew.
Think about it. Is it isosceles? What's isosceles mean? So when they don't have two of the same size, so what's the one that's called when all three sides are different? Remember that?
Scaling.
Very good. Scaling. Okay. So yeah, in an instance like this, it's telling you have segment lengths. It does not say that they're collinear. If they were collinear, they'd have to be on the same line, but if I'm looking at something like this, excuse me. Well, I mean, I don't know if you can make them all on the same line at all.
How many figured out that it was a triangle?
Nobody?
Yeah, no, there were a couple people. How many people figured out that it was a triangle?
Oh, I was thinking about the line.
I was too.
Now it can't be on the same line because if BC is 8, AC can't be 5, can it? Yeah, it would have to be 2. Does that make sense?
That's why I
I
was
can't
confused.
say that these guys are all on the same line because if you start putting it together, I hear you. I was walking towards you.
Okay.
If I put them on the same line, as soon as I say that BC is 8, that means that AC would have to be 2. But here, according to this, it says AC is 5, so it won't work. That's why we're able to do this and just kind of go, and we can make up a little triangle here. Okay, that's all. That's the kind of idea that we're working with. Okay, that's what you're doing with these things. Mr. Luna. Apparently you're famous.
Wow.
That's your picture.
Is that your celebration face? It is.
Come on! Come on! Come on! Killing me!
She told us to make the face when she's going up.
Killing us, small.
It's coming in. Oh, yeah. Brace yourself.
That was funny. That's the one time I laughed for.
Remember I spelled your name, right?
I forgot how to write.
You might as well stay here, because
Is there another picture? Yes.
get hit in the head.
Oh, you're getting his
Oh,
autograph.
autograph time. Boy, yo.
Oh, you know what? Get hit in the head.
Hey, I mean,
Where's the
we can do
ball?
this all day if you want to. I mean, you know what? I have no problem.
I took this.
Hey, you might as well go 4 for 4.
Oh, well.
One.
Apparently you were paying off a photographer yesterday.
It looks like you snapped it like that.
It's like, don't make
Hey, you know where the printer is outside?
in a Z
In the FTLA?
formation.
I'll print them, you want to go grab them off the printer?
Are you serious?
If I'm ever in the newspaper.
Yeah, I do this all the time, guys. I read the paper in the morning, and if I see students of mine that are in the paper that hopefully aren't in the blotter, what I do is I'll put your pictures in here and I get you to autograph it and we hang them on the back wall. As you can see, that's what we do. So that's why all that stuff's back there.
Yeah, yeah. Now since you just said that, I'm not gonna play basketball.
Okay.
I'm gonna try out for that.
So what conjecture can we make about Mr. Luna?
He likes getting hit in the head.
No.
It's the best number.
I'm not one for smart, but I'm not for history. But you put my.
Hey guys, this is something I've done for forever. That's why you start to see pictures on the back wall. Last year was a bit of an anomaly because I had Cole Tucker and I had Hannah Olberg, so both of them were in the paper like every other day last year. So, what's that? Yeah, so it's like one of those things, and it was just kind of fun. I've always done that. I always think it's kind of cool.
Yeah, it is.
One of the things was I also had. Do you guys remember Mrs. Johnson over at Rosette, math teacher? I've had both of her daughters, and her youngest daughter, I had her last year, and she went to school this year, and I was cleaning out some stuff in my cabinet the other day. You just on my desk. I'll hang them up later. And I, in her office, mailed her the pictures of her daughter that she had autographed, and it like made her day because my youngest daughter's at school. I miss her. So, and then the other cool thing is, and we'll do this again tomorrow when I get back testing to you guys about the whole fridge. A former student of mine emailed me yesterday saying that she got an A on her first math test in college, and she was so proud of herself. So I took a picture and emailed back. I put Caleb Baum's name on the fridge to help her out down there. She's playing soccer at it's like Northeast Alabama State or something like that. One of those. But yeah, she's down there playing soccer. So it's awesome. All right, so here's what we got. We actually just did this. Let's put this away. So what we just did a second ago, by thinking that maybe points A, B, and C were what we call collinear, we showed that it didn't work because we used what's called a counterexample. A counterexample is just anything to disprove what your initial hypothesis, your initial conjecture is. Okay? So if I look, earlier I said, I think Mrs. Thrower is 5'5". But let's say I said, oh, she's 6 feet tall. My counterexample would be to take a tape measure and realize, wrong. Things like that, okay? So when we said a second ago, I had the idea that points A, B, and C were collinear. Remember how I drew that out on a line? I started with points A, B, and I labeled it as 10. If I put C in there somewhere, the distance between B and C would have to be 8, and the distance between A and C would have to be 5. Well, does that work in that diagram? No. That's why we said that it is not collinear, because the counterexample doesn't, it shows that it doesn't work. Because last time I checked, 5 plus 8 does not equal 10. That's all it is. You're coming up with one reason to disprove something. That's what a counterexample is.
Sorry, I forgot to turn my sound off.
All right, does that make sense?
We didn't have my iPod.
You guys have all done that before. That is not new. Really? You think you have never done that before?
I broadly bring hypothesis.
Oh, no, I thought you were talking about counterexamples. Sorry. All right. So another one. Statement. Here's our general statement. X, Y, and Z are collinear. X is between Y and Z.
False.
True or false? Think about it. Give everybody a sec. Give everybody a sec. If you think that it is false, show some sort of a counterexample via a diagram and see what you can show. Because counterexamples can be diagrams. Counterexamples can be statements. Just like I showed a second ago, that 5 plus 8 does not equal 10. Can you come up with some example to show that it doesn't work? So what's your conjecture? Or better yet, do you have a true or false here? True. All right, so you say they're true, okay. Who says true? All right, I'm going to prove you wrong. I'm going to say it's false, and here's the reason why I can say it's false. My conjecture says that X is between Y and Z. Well, can't I say that Y is between X and Z?
Yes.
Yeah. So that means that the statement, the conjecture here is false, because I can disprove it.
So you can do ZYX.
But is it a definite statement?
How many counterexamples do you need?
Right, but can you disprove that conjecture? Yeah.
Yes, I can disprove that. I'll show you right now.
Oh, you just did.
I just did.
You just did.
That doesn't make any sense though, because one would be bisecting.
It
It
said
doesn't
nothing
say
about
anything. It doesn't
bisecting.
say anything about that. You can't just assume things. You don't want to make an angle side on you and me.
X is between Y and Z.
Right, that's the original idea, but I just disproved it, saying that Y could be between it. Z could be between X and Y.
They're still collinear.
They're still collinear, it's just not necessarily in the original conjecture. You're finding some way to disprove what the statement is. You're arguing with the establishment.
Oh, I do that, and so here's an example. So there's this propane storage company that wants to
Oh,
set up a
yeah.
house, like right across the street from my house, 725 feet to be exact. So the guy who wants to put this up is arguing before the county board that, oh, these places are safe, they're safe, they're safe, they don't explode, they're safe, they're safe. How many examples do I need to present to the board? See, I just need one counterexample. So I just go up there and go, Gurney, Illinois, a month ago. There was a huge explosion.
Yep.
So,
Yeah.
so you could say that they're
And
safe
you
all
think
you
about
want.
it, that would have leveled your house.
It would have,
Yeah.
it would have.
And if you guys were in the house, you guys wouldn't be around anymore.
Like like a 30,000 gallon.
Holy Jesus, that
There
must
was
have lit up the
a-
sky like 4th of July.
There was a problem with one of those going up to, was it Tower Lake, Wisconsin?
Okay,
I want to say it's Route 14 out of Illinois.
Okay.
There was a giant propane tank like that on the side of the road that didn't have protective guardrails on it. A car had a car accident, ran right into the side of it, and blew up the entire thing. And it leveled 3 or 4 houses that were near it because it didn't have the protection on it. This was 15, it might have been 25 years ago now, but it's the same basic idea. They didn't have the safety practices by putting it right next to a road. There's one like that on Genoa Road.
Okay.
There used to have there was a propane storage thing on Genoa Road, just about halfway between, what's the name of that road? Cherry Val and 90.
Okay.
So there was one out there that that didn't have anything around it, and now I think they pulled it. So,
And so
yes.
you guys, this is my favorite part of the geometry because you use it so much in life. Like when I rule the world, I'm going to require that a logic class be mandatory to everyone graduating from high school.
Wait.
Logic and reasoning is one of the
Oh
greatest
my
things
gosh.
you're going to have. Yes, sir.
Another recent example, like 3 years ago, a oil company was also into the propane and thing, and when the propane came off of the oil rig, and they put it into a ship, what was left of the propane. And anyway, this ship collided with another ship, and it went up.
Yeah, it's all about the safety things. That's why you have safety and regulations. That's why you want to keep regulations around for safety violations and things like that. That's why OSHA is important. That's why the Food Administration is around to make sure the food safe is there. That's why people have regulations to make sure that your drinking water is safe, all that kind of stuff. So that way you don't find a counterexample that there is lead in your water and you are all going to die. I know, right? Because it was deregulated and nobody was there checking it. Yes, sir. Anyway, second part of what I want to talk about briefly here are what are called if-then statements. And like we were saying, a lot of the chapter 2 stuff gets blended together a lot because there's no rhyme or reason as to do one section, do the next. It's more of a fluid chapter than anything. It's more about the topics that we can put together. And I think that utilizing this idea of what's called an if-then statement works out very well with the idea of this whole thing of conjecture. Yeah.
Is this like a hypothesis almost?
Almost, yeah. And that's what, if you think about, a conjecture is a hypothesis. So then you're using the idea of an if this happens, then this occurs, along with your conjecture. So we kind of meld them two together. Meld the two together.
It's like math.
Me spell
science,
English.
humanity. All of this.
All right. So what we're doing here is that we're going to use what are called conditional statements. There's going to be like you were just saying, a hypothesis that implies some sort of a conclusion. For example, this is a real difficult one. If it's first hour, then it's time for geometry.
Not every side, everybody.
Therefore, you can use a counterexample to disprove that. See what I'm saying? Now, if I reword that, if it's first hour for Austin, then he is in geometry.
What Austin?
Oh, shut up. Nicely played.
Austin Grant.
Okay. But that's the idea, all right?
Say Austin Grant next time.
It's okay. Guys, okay. Kids, chill. Enough. Write something down, it might help you. So, the idea is that we're able to come up with some hypothesis, some statement, some if statement, that allows you to have some sort of a conclusion. For example, oops, that didn't go very well at all. A generic statement looks like this. Two angles are supplementary if they are a linear pair. That's a pretty given statement. We knew that if, from our definitions from last chapter, we knew that supplementary angles add up to equal 180. Also, linear pairs add up to 180. So, actually I should rewrite this. Two angles are supplementary if they are a linear pair. Well, that's saying that if you have the linear pair, then they are supplementary. See how that works? So, in terms of an if-then, if two angles are supplementary, then they are a linear pair. I should write this adjacent supplementary, shouldn't I?
Oh, right, if they are adjacent and some.
Adjacent.
Yeah.
ADJCENT. Sorry, I forgot to put that word in there. Adjacent. Yeah, because supplementary means they don't have to necessarily be adjacent. I should have left it as adjacent supplementary. I just caught that. I typed that in incorrectly. I got a little ahead of myself. So if two angles are adjacent supplementary, it means they are next to, they share a common vertex, and they form a line. So two angles are adjacent supplementary if they are a linear pair. So if two angles are adjacent, then they are a linear pair. See how it works as what we call that if-then statement? It's a very, very simple way of writing things. It's a very easy way of doing it. You can do this in algebra. If x minus 3 equals 5,
X equals
then x equals what?
8.
That's it. That's an algebra statement version of an if and then. You've done that, you just didn't do the if part and the then part. What's that? Did you?
I don't recall.
Yeah, I don't think you did, but I mean, it's possible. But the idea is that you're just trying to come up with the idea of a basic statement. Can you turn it into this? See if I have another one here. I think I have another one. If I go, I use a little different notation than what the book does. P implies Q. If P, then Q. Where P is your hypothesis, and this is your conclusion. Okay. When the reason that I use the P and Q, you remember that from it's a college thing.
In an auto logic statement.
Yeah.
Right.
Everything.
Then you have until they match. Oh, yes.
So what I'm doing here is I'm using actual. We're going to use actual nomen. You know the word nomenclature?
Yeah, but I don't know.
Yeah.
From the Latin nomen meaning name?
So it's actual, what we're using is the real language of geometry, the real language of logic in a sophomore geometry class. Because we might as well. You know, it doesn't hurt any. You don't know any different. So I use this whole P implies Q, and you'll see how, I don't know if it showed up very well, but this is an arrow. P implies Q. Okay? So if you see that, means hypothesis, conclusion. So let's look at one more example. You've all heard this. If this had been an actual emergency, then the signal would have been followed by official information. You have all heard that on the radio before or on TV.
Oh, yeah.
That whole thing.
That's pretty good.
Thank you. You know, I stayed up late last night practicing. So, what would the hypothesis be of that statement? If it was an emergency, what's the conclusion?
There was a train by it.
More information to follow. You see how that works?
Okay, so basically you just, the hypothesis is that,
Actual emergency.
That's all it is.
okay, alright.
Your if is the hypothesis, your conclusion is the then.
Okay.
That's it. That's really all it is. So your hypothesis is, if an emergency, nah, you get the idea. If an emergency, then more info to follow. There's not a lot more, there's not a lot of stuff to this, really. And just like Madison said, guys, or I'm sorry, Grace said this. Sorry. She's not bitter, apparently. The if portion, 99% of the time, is the hypothesis. The then, the 99% of the time, is your conclusion. There are times when we have what are called, remember, biconditional statements,
Oh, yeah.
working
If and only if.
if and only if the if. Yeah, IFF.
Right.
It works going both directions, and we'll talk more about that stuff tomorrow and further on. I'm trying to think, I think that's about all we got. Oh, one more. I'd like you to turn this into an if-then statement. So you have perpendicular lines intersect. I want you guys to come up with some form of how you can word that into an if-then statement. Don't overthink it.
What's a perpendicular?
Huh?
What's a perpendicular?
That intersects into like this, a T intersect, like perpendicular.
It's quite literally that.
That's it.
Mr. Murphy,
It was
what's a perpendicular?
really.
Yeah,
That's why I said.
Really?
Yeah, really.
Perpendicular lines, lines that intersect form 90-degree angles.
oh, Forms just said forms a 90-degree angle.
It did. So in this case here, what would you say? We got him. Perfect. That's it. What else? Anybody else something different? Very similar. Yeah. Ah, careful. I can counterexample that. Lines, you said lines intersect and they are perpendicular. Those lines intersect, don't they? They're not perpendicular, right? So what you have to remember here is, what is the basis of the statement? The statement is perpendicular lines intersect.
So can you have perpendicular lines intersect and they won't serve each other?
You're even making it more difficult.
Oh.
All you have to say really is, if perpendicular lines, then they intersect. It doesn't have to be necessarily overly complicated. And you'll get used to this, because I got like 3 or 4 of these for you to work on tonight. Whiskey, what do you got?
If two ways, then they form a 90-degree.
I don't see anything in this generic statement that talks about rays or 90 degrees. Do you? You can't make up words that you don't see. All right, and that's you guys, and that's a very common mistake. Don't try to make up words. Okay. So here's what I want you guys to work on this evening. We'll stop here and we'll continue on with these things tomorrow. Perfect.
Where did you take a nap?
I'm ready to go on my mind.
Yeah. SEC. That's our math homework?
Yes, sir.
Holy.
So it's kind of a melt. It's a mix between the 2-1 and the 2-2. Yeah, just go to the link on the book, and just go look for section 2.1, 2.2, and then just go over it. Yeah, it's in the textbook. Yep. Yep, that's all it is. And then we'll go from there. We'll work those through. We'll finish up the last bit of 2-2 tomorrow, and then, like I said, we'll go through the logic stuff.
Yeah, you guys, and this was great timing because there were political debates that were on you can watch it on TV on Monday night. Listen to the politicians' statements, because what they're saying, even if they don't say, if this happens, then this happens, the statements that they're making, you can turn into these additional statements.